Hello friends, this is Eli from Mystic Circuits, and today I'm going to be showing y'all how to build a 0 HP 0ttenuator. Here we have a full kit. All the parts and everything you need to make it are inside, including our handy dandy instructions, but like to make sure that people have more thorough instructions. So here we're going to be showing the entire build process without fast forwarding or skipping through anything. If you fold this open, you'll see this as well as a little piece of paper with all of the parts. We're going to go ahead and check all the parts. Since you're following these instructions, I'm going to assume that you don't need these necessarily, but if you want an even more detailed and step-by-step instruction written down, you can use this QR code to go to our GitHub and find that information. There's a good chance that you're here because you went through our GitHub. I apologize. I'm going to bonk the camera a little bit because it's hard to maneuver with all these different parts. I'm going to do my best to avoid it, but it's going to happen. So you'll see a second box over here. This has the circuit board and various other pieces in it that are sort of used in all of our different builds, so it's easier to pack those along the way. But basically, we're going to go through. You'll see on here, you've got 2 resistors and 2 potentiometers. Put that to the side for now. Go ahead and look in here. We're going to find the top and bottom of our case. You might see this on the back side. All of our lids are 2-sided in order to save some dough. So if you have the top and bottom, go ahead and put those to the side. You might see the main circuit board right here. It should say 0ttenuator. I believe it's our only black circuit board, so that's what we're going to be building. You should see 4 jacks. Put those over here. There's going to be 2 long sides and 2 short sides with little holes in them for the case. Go ahead and put that with the other parts to the case. And then here we have the case hardware. 4 rubber feet, 4 screws, and 4 nuts. Right? So as long as you have verified that you have all of those, go ahead and put those to the side as well. If you don't have any of those, please shoot us an email so that we can get you some replacement parts. Go ahead and put these out for a little while just so that we can keep track of everything. Wait, these nuts are kind of hard to move sometimes. I'm just going to shove them over there. All right, so here we have all the parts that need soldering, right? And what we're going to do is we're going to take off these resistors and these pots just so that we can have everything in the same place. And I have a certain order that I like to do all of this with. You don't need this piece of paper anymore. By the way, if you've never soldered anything in your life, you should go ahead and take a look at our how to solder video. That'll be linked below. It goes over the absolute basics of good solder technique, how to know that you have soldered a joint correctly, and just other advice that we have for dealing with solder, doing so in a safe and healthy way. Okay, so I have my soldering iron over here, right? And one of the most important things when you're soldering is every time you're about to start soldering, you do what's called tinning the iron, right? And basically, I'll go ahead and move this over here. What that involves is putting a little dab of solder on top of our iron and making sure that, adjust my solder sucker a little bit, making sure that the entire tip is nice and shiny. I'm going to go ahead and do that. I also have a sponge here. Helps with getting the excess chemicals off. And as you can see, our soldering iron is nice and shiny on the outside. You don't want any brown or black stuff on the sides. And if it's there, you know, sometimes it gets there and then it doesn't come off. You just want to make sure it's minimized and that there's a shiny spot on your soldering iron that's able to accept solder. So I just took the little piece of paper tape that kind of keeps the soldering or the resistors in a group off. Now we're left with a flat resistor. What we're going to do is we're going to bend the legs down in the same direction, so it makes a little U shape, right? Almost like a staple. Then I'm going to go ahead, I'm going to put these into these two rectangles on the sides of the 0 HP circuit board, like this. And I'll show you what I did on the bottom really quickly. So I put the legs through into these holes, push the resistor all the way flat against the board, and then flip it over. And you're going to want to bend these legs out, right? And I'm actually going to adjust the legs because, you know, brilliantly when I designed this thing, I didn't think about how there are 3 solder points all really close to each other. So we're actually going to bend the legs into more of an X shape like this. As you can see, when I bend the leg in this direction, the leg is going away from these 2 lugs that are next to it. It's not, you know, a huge problem, but it is annoying. So we're going to go into this sort of X shape, right? Hopefully you can see all of these together. You can also just solder one resistor at a time. In fact, why don't we go ahead and do that? That'll make it a lot easier. So if you're more advanced, you can go ahead and solder the resistors the way that they are. But since this is a very much supposed to be a beginner project, I'm going to go ahead and take this resistor out. Now we just have one resistor in on this side. Flip it over. It's in this sort of X shape, right? And what I'm going to do, because I left my iron alone for a little bit, I'm going to tin it again. I'm doing this off screen because I have a fume extractor in my room that I'm working in. I'm next to a window, but it's very awkward to get the fumes outside. So what we're going to do now is I'm pointing my iron sort of like in this direction along the direction that the leg is going. A lot of people think you take the point of your iron and you just stick it on the joint. That's actually not right. What you want to do is you want to maximize surface area, right? So you want it to touch the iron and ideally the circuit or the leg of the resistor you're soldering, and ideally the circuit board underneath it, right? We're kind of going along the direction of the leg. That helps keep the heat up, and then we're just going to dab a tiny bit of solder in there. We're going to do our best not to get the solder joining this node and this lug and that lug. And if you do, just take your iron and kind of like wipe it away like that, right? Do some of that. Make sure that this joint isn't touching either of these two. And if it is, you can go ahead and fix it later too. But we're going to go ahead and do this leg now, pointing in the other direction, right? Just kind of barely touch the solder to the joint. Oh, still not warm enough. And then to check these joints, what we're going to do is we're going to just go ahead and look and see that we can't see the little hole on the circuit board where the leg is supposed to go. And then when you bend these legs up and you wiggle them around, you can see that if I wiggle this leg around, you can see that the little ball that's attached to the circuit board isn't moving around, right? If you could see the solder that's actually on your board moving while you're doing this, that means that you've got to go back and resolder it, right? So next we're going to leave these legs up, right? I'm going to put the other resistor in. It's back in the circuit board. You can see on the other side, we're going to bend these legs over in order to help keep the resistor in place. And I'm going to go ahead and hit these legs with a bit of solder. You can see I'm, again, going in the direction that the leg is pointing. All right. There we go. And we're just going to wiggle these around. It looks good. If at any point you get solder into these holes, it's best not to, but don't worry too much about it. You can always heat up the point before. I'll show you what to do later. But now that we've verified that all the legs are working, I'm going to grab my snippers, which of course I left over here. All right, got my snippers. We're going to go ahead and take each leg and cut it off, throw it away. And do your best to get as close to the board with these cuts as possible. I can see this leg sticking up a tiny bit, so it's able to fit into my strippers. I'm going to cut that off. And now we're going to go ahead and move towards the jacks. So on this design, you take these jacks, all of the jacks, the actual hole where the cable goes in is facing out of the board, right? And I'm going to go ahead and show you if any of you got some solder in this hole and you can't fit it through, what you're going to do is you're going to go ahead and put it in as far as you can, right? And then you're going to kind of take your iron and heat up the hole while pushing it through. Keep in mind that this can make the jack kind of hot. So try not to burn yourself. Touch the plastic part rather than the metal. But hopefully you'll only need to do it a little bit. You can also use something called solder braid in order to remove solder from holes. It's a good thing to have around, especially if you're getting started with DIY. You're inevitably going to get to a point where you need to take some solder away from something. Solder braid's a really good way to do that. So now I'm going to tin my iron again, just because it's been a little while. You can already see, you could see it shiny on this side, but on the other side, it's starting to get dull. You see that? That's what we want to avoid. And I wish I had some tip tinner with me, because I can tell that this iron is going to start getting crummy. But basically, just put, here, I'll show you. I'll put some solder on, and I just keep feeding it on until the ball starts wiggling around and falls off like that. And then you clean it off. You can see it's a little shinier there, so I'm kind of going towards the edge of that area between the shiny and the brown part, trying to sort of expand the shiny part. So that as much of the iron is covered in solder as possible. And then we move on, right? So next up, we're going to solder these jacks. The jacks, sometimes they take a little bit more heat than what you might want. So usually what I do is I solder all of the points on the edge of the board first. And this is because if the jacks are not in the right position, like if any of them are a little bit lifted off the board, you won't be able to put the case together. Right. And so what we want to do first is we want to make sure before we solder all the points on that the jacks are going to be in the right position. Right. So now that we have just those 4 points soldered, I'm going to take one of the sides of my case. I'm going to put it over the jacks just to make sure it fits on. Same here. You can also just look at the side. I think the text is what was freaking out my autofocus. Let's see. Lighting isn't awesome in here either, but if you look at the side, you can see that these jacks are laying perfectly flat against the board. You wouldn't want, maybe if one of them was sticking up, it might look something like this. You see how you could see across the bottom of the jack? really hard to do this while looking at my monitor. You see how you could see a little gap in there? That's what you want to avoid. So just kind of press the jack back into the board. Make sure they're all flat against the board. And now we're going to do the rest of these joints. So I usually like to solder in the direction of the joints that I'm doing so that I can put the iron flat against it. It helps, like I said earlier, with the heating of the joint, making sure we can avoid what's called cold joints. Nobody likes a cold joint. See, and then I rotate the entire board, and I'm going to do these 4. You know, the best way to make sure that these joints are good is to make sure that the hole is filled with solder. You can see everything looks nice and shiny. I can't see any of the holes. There's these little Hershey's Kiss shapes of the joint kind of arching up towards the pin that's going through. So everything's looking good. Here's what it looks like on the front. Right, and the reason I do the jacks first on this design is just because it's one of the few designs where we have a big silly thing sticking through the top. These pots are going to stick up, and we're going to have to do a similar thing with the jacks where we make sure that they're flat against the board. And they're kind of a pain to actually put in. What you're going to have to do is take your finger and kind of pull against these pins, make sure that they're all flat in a line and kind of stretched out. And then you take your finger here, you see these 2 little legs sticking off the side. What you're going to do is you're going to put your fingers on both of them and kind of pinch it in. For whatever reason, I think it's because you want a little bit of force going against it to help hold it in place, right? So we have 1 pot right here. And what I'm going to do, and we're going to do 1 pot at a time, all right? So actually, that kind of makes it harder to solder. So we're going to do both pots. I changed my mind, all right? Pinch a tiny bit, kind of pull these pins out, place it in. You should be able to feel when, you see how I bent the pin a little bit there? You don't want that to happen. So I'm going to bend it back in place, make sure they kind of look evenly distributed. And I push until it's in a line. Pinch these again because I don't think I did it enough, and then kind of place it in, and you'll feel it snap into place mostly, right? And what we're trying to do at this point, right? You see how this pot is flat, but this pot is sticking out at an angle, right? What we want to do is we want to kind of push on the top until it sits back in place, and it'll kind of snap in, like I said. So kind of wiggle it around a little bit. Now what we're going to do is we are going to solder 2 pins on opposite corners. You'll see me do this a lot. We solder this pin over here, this pin over here. These are both the rightmost pins in the sort of line of 3 pins that makes up the potentiometer. Why is this not? You might have to kind of like figure out a creative way to press into it. So right now I'm holding the board in one direction. I'm pushing against it just to kind of make sure that it makes a good joint. This one's being really stubborn. I'm going to try it from this other direction, right? Sometimes you might have to be creative. I can't sit there with you. Your soldering iron might work different. You know, it might be a different temperature where you are. Sometimes you got to get creative with soldering, right? So that looks pretty good. Next, I'm going to go against this big flat tab right here. Kind of push solder into it until the tab looks like it's making a nice connection with the rest of the board. Yeah, so you can see this is the tab that's been soldered. This is the tab that has not. Right, you can see the hole around the entire tab. And the thing that this does is it makes it so that our pots are being held nicely in place, right? Because if we don't have it in the right configuration, it is not going to sit in our case, right? And we're going to sort of do something a little special with this one. What we're going to do is we're going to put the lid on, right? And how you could tell it's correct is, the text here, it says Mystic Circuits, same orientation as the text on here. 0ttenuator, 0ttenuator. Mystic Circuits, Mystic Circuits. I can read both of them without having to look at one of them upside down, right? I'm going to put it over the pots. It's a good start that it fit on without any awkwardness. And then we're going to go ahead and put the short sides in. You can see that this tab right here matches up with a hole in the case. So I'm going to go ahead and do this. Slot it into the hole. Do this. Slot it into the hole. And so now we can verify that once we've assembled our case, right, and this is sort of what it'll look like. You'll see the two short sides are in. They're both with the tabs in their respective holes. You can see these holes are empty because we haven't put in the long sides, right? But basically, this is all fitting together without you having to force anything, right? And if you turn these, you shouldn't feel the plastic part of this pot kind of scraping against the sides. If anything like that is happening, what you got to do is you have to heat up one of these while pressing the pot on the other side in the direction of where it's supposed to go. I realize that's kind of an advanced maneuver, but I'm just letting you know it's going to be so much easier to do this at this point in the stage rather than whenever you've soldered all of the parts on, right? And if you're not doing this with a case, that kind of helps. But this is really the stage where you want to make sure that everything fits on nicely without the pots either sticking out in, diagonal directions or scraping against the sides. So I'm going to go ahead and turn each one, verifying that neither is being scraped. Everything seems good. Everything fits in the case nicely. So now I'm going to go ahead and solder the rest of these pins on. So you can see these two lines of 3 pins. What we're going to do is we're going to go up against the side of each one, drop in a little bit of solder. We want to be careful not to connect any pins together. And I'll go ahead and do it on purpose just to show you what to do in case some of the pins do get connected together. Right, so here we can see we have a point with 2 pins that are supposed to be separated, connected with a big blob of solder. It's supposed to look like this with 3 different pins. Instead, it looks like this with a short pin and then a big long pin. All you want to do is you kind of put your iron in between the two until it heats up and you can see the iron actually go between the pins, and then you wipe that excess solder away, right? The solder wants to be on something hot, right? And then we're going to kind of just like reheat these pins in order to make sure that they really are in a good position, right? And there you go. Now, it's optional to solder these tabs, and I would say if you're already having difficulty getting the pots to sit in nicely, you should just leave those tabs unsoldered just to make sure that you can rejigger everything later. Also, you want to make sure at this point that these resistor pieces right here aren't in contact with any of these. And just to kind of illustrate the point I was making earlier, let's do it on purpose, right? So I'm good enough at soldering that I can make problems for myself on purpose, right? So let's say that you have these 2 pins are connected together. We're going to do the same thing we did with those pins before. We're going to put the iron in between them until both are heated up, and then we're going to sort of wipe and try and drag the solder away, right? Then we're going to take our iron, we're going to try and reform each one. You'll see the entire solder slowly start to melt. And then once you look close, you should be able to tell that there's no connection, right? I have a pair of magnifying glasses that help me identify these sorts of problems. They're really handy for this sort of thing. So because I've done this 1,000 times and I know that my case is going to fit on, I'm going to go ahead and solder these tabs. Again, it's not necessary. They don't form a part of the circuit. It just holds the pot stationary, and if you are having trouble fitting the case on, I suggest not soldering these tabs. But now we go ahead. Our knobs are turning easily. And so now I'm going to go ahead and put on the long parts. The nice thing about this is that we've already done a lot of the work putting the case together. Now, I generally like for my logo to be sitting up instead of upside down. You can technically build it this way, but you know, why not have it all look nice and proper, right? You'll see that this tab fits in to the top. I'll do that one more time. Actually, I have to do it on this side anyway. So you can see that there's this opening. Just like with the short sides, there's tabs on the top and bottom. Unlike with the short sides, you're going to have to fit the tab into the top while also doing the tabs on the sides that sort of fit together. So you'll see it. There's a long piece and a short piece that fit together like a puzzle piece, right? And if you're trying to force a piece of circuit board into another spot that already has circuit board there, just flip it around, see if it works better that way. It all fits together like a puzzle, right? So like this. Now we'll take the bottom, and there's two directions it can go. One of them, you're just going to have to sort of rotate things until one of the tabs fits with the rest of them, right? You can sort of see here that the tabs are all lining up. This one is sticking out a little bit, but right here, right? And so I kind of start with one side, right? These two tabs are in, and then I'm going to sort of press the rest. You'll see, you sort of heard and felt it all snap into place, hopefully, right? And now, you know, maybe check before doing all of this that your knobs are rotating this way, that they're able to point straight up. If your knobs are pointing down from here, your circuit board is upside down. I don't think you can act like the knobs are slightly offset. I don't think that's technically possible, but it's a good time to check. So now we're going to put in the case hardware. Again, we have these bolts, we have these rubber feet, and we have some nuts. And what we're going to do, the nuts are really hard to grab on this rubber mat, but what we're going to do is we're going to start with one bolt. You take it, you push it through. You might kind of have to force it towards the end if the holes aren't perfectly aligned, or just wiggle it around or something. And we're going to do these one at a time, right? So the rubber foot goes over the bolt, and then the nut goes on the end. And if you just flip it over, the nut is probably going to fall out. So you're going to have to take your finger, place it over the nut, and turn it over so that it's holding the nut in place. And now you're going to take a Phillips head screwdriver and tighten the screw. You might have to kind of like push into the nut in order to get the teeth on the bolt to actually mate with the threading in the nut. But you'll feel when it starts to tighten, right? And the nice thing about this first screw is that it kind of helps us keep the whole case together. I'm going to go ahead and do it on a second one. Place my finger over, tighten the screw. I'm kind of pushing from the side in order to help with the nut mating. All right, third screw. This one, as you can, I'll show you really fast. You can sort of see, even as I'm tightening the screw, the bolt isn't going in. You might have to kind of pull it out and reset it, wiggle it around a little bit until it goes. Now, maybe you can see how making 20 of these things, 30, 50 of these things, it's very time consuming. But these cases, I love how they look, and they're extremely durable. Right? So, all right, I think that one has been satisfactorily tightened. All right. There you go. Your very own 0ttenuator. Here we go. Mystic Circuits 0ttenuator. Yeah, if you have any questions, if you ran into any issues, go ahead and either leave a comment or get in touch with me through my contact page. Yeah, this is one of the simpler builds. There's a couple places that are tighter than they should be. Yeah, hopefully everything works for you. I will say I've run into a couple of problems where I'm going to go ahead and untighten these, just because if you built this and it's not working, I have one suggestion for what to do, right? And this is, in fact, a design issue that I should have seen coming. Part of the reason that I am discontinuing these modules is because I don't know if you noticed, but there's this big piece of metal on the back. Well, as it turns out, there's a big piece of metal on the inside too, right? So if you look here and here, it's possible that you'll have a version that doesn't have this big metal piece, because I am planning on replacing that in the future. But if it's possible that one of these pins on the inside is making contact and being bridged through there. So if you built a unit and it doesn't work, what I suggest doing is cutting some of these tabs. And what I'm going to do, I'm going to take these sides off, and you'll see here I'm doing all three at once. It's pretty easy to do, but if you don't feel confident with that, you can just do one at a time. 1, 2, and it's taking a sec between each one because I'm reaching under my table and just throwing it away directly instead of making a mess. We're gonna go ahead and take these pieces off, these pieces, this one, this one. Don't worry, we don't have to take all of them off, but I would suggest also just doing these two just in case. And yeah, I'm going to go ahead and put this on. Put this on. And then I won't show you me screwing it all back together again, but you can see sometimes the pieces get a little misaligned. So I'm just going to push in here, lay it all together. There you go. You have your Mystic Circuits attenuator. Go ahead and leave a comment or get in touch with me if you have any issues building this. And yeah, thanks for watching. Okay, we're going to go ahead and do a little demo patch to test out our attenuator. We're going to have 2 sound sources plugged in here. I plug in through both of here. I have a sawtooth and a triangle wave from the Schlappy 3 body coming in, and I'll plug into the mix output. You can hear one going up, the other coming up as well. Now we go here. We should only hear one, and if I unplug from here, you should hear the other source. And then you can, if you really want to, just go ahead and verify that that source goes out the bottom. So, yep, that should be enough to test out your brand spanking new 0ttenuator. Hopefully this was a fun and successful build for you. And yeah, happy patching.